Welcome to the final challenge in White Rabbit's series of missions to learn more about low Earth orbit satellite technology and development. These missions enable you to guide a virtual satellite design through the development stages that a real satellite undergoes before it enters orbit around Earth. I'll recap what you've accomplished. In Mission 1, you identified the type of satellite we need to build. In Mission 2, you shopped for all the components. In Mission 3, you tested and corrected your design virtually using digital twin technology. Now, it's time for Mission 4, Shake and Bake. This is where we'll test your hardware to make sure it will hold up to the extreme vibration during launch and the harsh space environment which will be its new home. Shake and Bake is the industry term for the crucible of tests to simulate launch, deployment, commissioning, and operation of the satellite. Most of the environmental factors that affect a spacecraft in space are not at any relevant levels on Earth, if at all. So testing chambers must be used to create these conditions on Earth. High energy radiation can be created using particle accelerators and allows electronics to be tested separately in much smaller chambers. If you have heard the term rad-hardened, this is not the name of a rock band, but a way to describe electronic components that can withstand high energy radiation. The other main factors affecting spacecraft are 1. Vacuum, 2. Thermal energy from the sun, and 3. The non-reflective nature of space itself. We're going to use a vibration table to simulate launch, which is kind of like riding a controlled explosion for 3 to 4 minutes straight. Each of the components you chose were already certified to perform well in LEO, which means they won't be subject to outgassing as much as in GEO. Because of the vacuum of space, all materials will evaporate, even if just a few particles at a time. This rate increases with temperature. The evaporated material can then condense onto other components and cause them to malfunction. Imagine a computer motherboard evaporating inside your gaming computer. It's hard to imagine, but this is what can happen if the wrong components are used. We'll use White Rabbit's vacuum and chemistry lab, equipped with a thermal vacuum chamber, to learn more about outgassing. Testing for resilience to heat is easier than testing for absence of heat. In deep space or eclipse, nothing is nearby to radiate, conduct, convect, or reflect energy onto the spacecraft. This means the spacecraft will eventually cool to near absolute zero if it is not exposed to some form of heat radiation. You are ready to complete your mission. Good luck.